By this point, you know that insulin is needed to balance glucose in the body and that bolus insulin is given at meals and to correct high blood glucose. Nearly every meal that a person with type 1 diabetes eats will need to be accompanied by a bolus insulin dose. In this video, we'll discuss the steps for giving insulin at a meal and explain how to use the insulin-to-carb ratio and correction factor to calculate insulin doses. The steps for every person with T1D when eating should be 1. Check the current blood glucose. If the current blood glucose is equal to or below the person's correction target, they only need to cover the carbs in the meal. If the current blood glucose is lower than 70, then the low should be treated first using the rule of 15. Once the blood glucose has risen to a safe level above 70, then you can give insulin to cover the carbs in the meal. Remember, you should never give insulin to cover the carbs that were eaten as part of the rule of 15 to treat the low blood glucose. Once the low is treated, you don't need to correct the blood glucose even if it is higher than 180. Just focus on covering the carbs. If the current blood glucose is higher than 180, then you should give a correction dose along with the carb dose. 2. Calculate the amount of carbs in the meal using the nutrition facts or by weighing the food with a scale and consulting a nutrition book or carb counting website with the weight of the food. Multiply the weight of the food in grams by the amount of carbs per gram of the food item to get the amount of carbs in the meal. 3. Use the carb count and the insulin-to-carb ratio to calculate the number of units of bolus insulin to give to cover the carbs. You can use the calculation sheet for insulin doses available and if you're giving a correction dose at the same time, you will use the current blood glucose and the correction factor to figure out how many units of fast-acting insulin to add to the total dose. We'll go over an example using the calculation sheet in a moment. 4. Give the insulin injection. 5. Eat. This is the calculation sheet for insulin doses. Let's use this to calculate the insulin dose for an example snack. Let's imagine a child with type 1 gets home from school and is planning on eating a bag of chips. The entire bag is 1 serving, and the nutrition fact says it has 25 grams of carbs. Let's imagine the child's insulin-to-carb ratio is 1 unit for every 10 grams. To calculate the insulin that will cover the chips, they divide 25 grams of carbs by their carb ratio of 10 for a total of 2.5 units of insulin. If the child only plans to eat half the bag of chips, they would first divide the 25 grams of carbs by 2 to find the amount of carbs in half the bag. 25 divided by 2 equals 12.5 carbs in half the bag of chips. Still using the same carb ratio of 1 unit for every 10 grams, they would divide 12.5 grams of carbs by 10 for a total of 1.25 units of insulin. If the child's current blood glucose is higher than the target range, you may need to give a correction dose as well. To do this, subtract the child's correction target from their current blood glucose to get the amount you need to lower the blood glucose by. Then divide this number by the correction factor to get the number of units of insulin that should be delivered. Let's pretend in our earlier example that we were talking about a child with a correction factor of 1 unit for every 50 points above the correction target. Their current blood glucose is 220, and their correction target is 120. We'll subtract the correction target of 120 from the current blood glucose of 220. The result is 100 points that we need to lower the blood glucose by. Now, we'll divide this answer by their correction factor of 50. 100 divided by 50 is 2, so we should give 2 additional units to correct the high blood glucose in addition to the insulin given to cover the chips. The total for this snack would be 3.25 units of insulin. If you do the math for a bolus dose of insulin and get a result that is not possible to deliver, you should round the result up or down to the nearest available dose amount depending on your current blood glucose level. The child in this example should round 3.25 up to 3.5 units of insulin or round down to 3 units of insulin, depending on their current blood glucose level and expected activity level. When eating a snack, it is important to consider these conditions. Another digital tool that may be helpful is MetricSync, an app designed to estimate nutrition information from a photo of your meal. The app can calculate estimated macronutrients and insulin dosing information, which may make meal tracking more convenient for some users. MetricSync offers a free 3-day trial followed by a subscription of about $5 per month. The company reports accuracy of around 95%, though users should still verify results and follow the guidance of their healthcare team, especially when making insulin-related decisions. You can learn more at metricsync.download.